I'm going to start sharing my screen here.
Fun times.
All right. So we'll take this time at the beginning to talk about actually, no, we won't talk about that yet because I want more people to hear. So I made a PowerPoint. I'm really excited. Oh, I'm going to move my little box over here. Okay. So we rescheduled this because I forgot to remind people. And also I wanted to try an afternoon session because I thought more people would come. We will see if that's true. Our topic today is going to be space exploration, right? You probably noticed if you started Module 3 or if you are in it, it's about space, right? It's about seasons. There's actually a lesson called space exploration, and it's not going to be nearly as cool as what we're going to do right now. So, oh man, now I got to move this thing again. Okay. So in this virtual session, we are going to describe how our views of space have changed over time, discuss the impact space has on ecosystems and the Earth, and we're going to work in groups to make a mini presentation about a space voyage. So first thing is, a lot of people were getting kind of stuck on this lesson about how our views have changed, right? And this is the biggest way that they've changed. Obviously, there's a lot of other things now that we have more technology. It's much easier to study space when we can actually go to space, right? Or we can send satellites, or we can send machines to collect data from space. Because 300 years ago, people just looked up and knew that space was there, but they didn't really know what was going on, right? So the original view of the world was, geocentric, right? Geo here meaning like Earth, that Earth was the center of the universe. Everything revolved around the Earth, right? You can imagine that because we're humans and we're really selfish and we obviously think everything is about us, we were like, yeah, Earth is the center of the universe, duh, right? And then eventually we figured out that no, actually the sun, I wrote the sun is the center of the Earth. Whoa, that doesn't make sense. Let me escape out of that. Fix that really quick. So the sun is the center of the universe, is helio, right? And the helio part of that word means sun. So that's like the biggest way that our knowledge has changed. And then just as a side note, Mr. Ling told me about this really awesome app. It's called Exoplanet. And I think it's free, and you can download it on your phone, and then you can see a 3D version of space. So you can actually like zoom in on Earth, and you can see satellites and where they are, and you can zoom in on planets, and you can like tilt around like you're in 3D. So if you're interested in space and like you like to learn about what's going on, that's a cool way to play around and like look at a galaxy on your phone. So here's a picture of that exact thing that I just described, where we have, I don't know where to put this box so it's not in the way, whatever. All right, so we have our geocentric version of the universe here, where Earth is in the center and everything is orbiting around Earth, right? And then we have our current day model where we have the sun in the center, right? And everything is orbiting around the sun. Seems really basic. You're like, all right, well, I always knew it was around the sun, but this was a big revolution in the way that we thought about space and about time and how things work. The other thing I wanted to talk about is how space impacts ecosystems. Because a lot of times people think, all right, we're learning about space. Either you're like, whoa, this is so cool, I love space, or you're like, space is boring, I want to learn about living stuff. They're really closely related, right? A lot of these things going on in space are actually impacting living things. And sometimes we don't realize that connection, right? So the biggest one is that the sun is giving energy to plants, right? That's a huge deal. Without plants, we would die. The moon's gravity is creating tides, right? Tides are important for certain ecosystems. Some animals only live right where the tide is, right? So they wouldn't be able to live without the moon. And then the rotation and the revolution of the Earth cause seasons and day and night, right? So the Earth rotating causes day and night. The Earth revolving and rotating causes seasons. So there's big connections here to living things, right, to ecosystems. And there's even this theory, right? I went to this lecture about what killed the dinosaurs. It was really cool. And this guy was providing all the evidence for how a meteor was responsible, right? And he's talking about that. And he's talking about how there's even these theories about the galaxy tipping, right? Every 300 million years or something like that, the galaxy itself tilts slightly a different direction, and that those tilting events might actually cause mass extinctions on Earth, right? We've had 5 mass extinctions in Earth's history, where in some cases up to 95% of living things were wiped out completely, right? Sometimes those were caused by meteors, sometimes they were caused by volcanoes, right? Sometimes a combination. So there are these connections between space and ecosystems and living things. So going into, you're late, but you're fine. You basically missed me talking about heliocentric versus geocentric. That was pretty much it. All right, and dinosaurs. Sorry, I just couldn't help talking about the dinosaurs. I just love it. Okay, it was a cool lecture. So you guys have probably seen a picture like this if you've done the lesson on seasons. If you haven't, you're going to be doing it soon. So you can tell based on the tilt of the Earth, right, and where the Earth is in relation to the sun, we get our different seasons, right? And then as the Earth is rotating, we get day and night, right? So a big impact on where things can live, when they can live, right? We all know about seasons, right? What season are we in right now? The rainy season. But notice there's lots of plants, right? That's something interesting about the Pacific Northwest. There's grass right now, and it's winter, and there's grass, right? Or fall, winter, it's about to be winter. There's grass, right? That's weird. In other parts of the world, in the winter and in the fall, everything's dead. It's just dead everywhere, right? So all that rain actually does help us there. All right, we got some, I'm gonna mute you, Riley, because we got some crinkling going on there. All right, so then I thought we could watch this very short video. It's this guy's vlog, and he's kind of annoying, but I thought at least he was entertaining so that we could kind of watch him. We could talk about him after and about what he says. He also has this really elaborate intro.
All right, we're back with another blog about the moon, and this time it's going to be on tides.
He also doesn't call it a vlog when it's clearly a vlog because it's a video blog. Come on, guy.
Why do we have tides, and why are they caused by the moon? Most people can tell me that tides they're caused by the moon, right? Well, why? Even if I asked what about the moon, people would tell me it's gravity, which is correct, but then what about the sun? Isn't the sun like a lot bigger and thus has a lot more gravity? So why does the moon affect us more than the sun when it comes to tides? Let's take a look. So the moon causes tides because of the moon's differential gravitational force. What? So differential gravitational force, it's not that bad. All it means is that the moon pulls on the Earth differently. So the moon is closer to this side of the Earth right here in the front, right? So it's going to pull on that actually 6% more than the back side of the Earth because it's actually farther away from the moon. Gravity's a force, and it acts as you get farther away from it. It doesn't, the strength isn't as strong. So the stuff on the front side of the Earth here gets pulled on the moon 6% more than this side. Now the sun is really far away, and it doesn't see us as well. It does have differential gravitational force, but it basically treats the Earth as a point source. Not completely. That's how we get spring and neap tides. I'm not going to go into that, maybe in another blog. But the sun, because it's so far away, doesn't exhibit as strong of differential gravitational force as the moon does. Because it's so close, the moon can actually treat us like a sphere rather than a point. And that's how we have differential gravitational force. So this is a program that my boss, Dr. Bradstreet, and his best friend, Dr. Stillman, wrote. And it's going to help us understand tides. I can move the moon, I can change its orbit, I can do all kinds of fun stuff. Now, we need to know what the Earth is feeling at any given point on the surface. So to do that, we actually have to first look at the middle. You see here's a vector. A vector is just a force in a direction, and you can see it follows the moon. Kind of cool. So what I'm going to do now is put on what the Earth.
So notice as he got farther away, right, as the moon gets farther away, the vector got smaller. We can still see it. It's like a tiny little green arrow here. That's because gravitational force, which you guys didn't necessarily learn about, it's actually a mathematical equation, right? And the further away things are from each other, the less gravity there is between them. But technically there's gravity between any two objects. So if we were standing next to each other, there would be gravity between us, right? It would be really weak because we have a tiny mass, but gravity would be there, right? So you can, in fact, we'll make cheesy Valentine's Day cards that say that, like, there's gravity between us, because it's true, right? Every object has gravity with another object. The thing is, once you have huge masses, then that's when it's going to start mattering, right? And in this case, when the moon, he's kind of showing this because, like, the sun is so far away. So even though the sun is huge, it's so far away that it doesn't impact us quite as much.
Earth feels at the different cardinal points. So if you were here on the side closest to the moon, you can see it's a pretty strong force, right? And as I move these around, they follow the moon. Now, looking at this, I would think that this is high tide, that's low tide, and these are like normal tide. And sadly, I'm wrong. This is high tide, that's high tide. This is low tide, and that's low tide. And to understand that, we have to understand what each part of the Earth is actually feeling. To do that, we have to subtract out the middle vector. If you understand math at all, you'd understand this. To understand what this part of the Earth feels compared to this part of the Earth, we have to subtract that out. So let's do that. Let's subtract out that middle piece, and let's make it a little obvious. So there you go. I put in a vector now that's subtracting out the middle. I've canceled out the middle by putting its exact vector on top of it, and then I put that vector on each of the other vectors. So now what is the resultant of?
So he's getting very technical here, right? Which this kind of goes above and beyond the scope of the class. But the reason that I'm showing this is because I want you guys to understand that there's actually like a lot going on here. It's not just the moon causes tides, right? It does, but then this is getting into the math and the physics behind it, right? Which is interesting. We're having to actually subtract different pieces of force happening on the Earth.
This. What is the resulting force? That white arrow is the resulting force. So if I take the red plus the orange, I end up with the white. If I take the red plus the orange, I end up with this little white. If I end up the green plus the orange, I get nothing, which is what we expect. And then you can see here, that's the resultants for the rest of them. Now I'm going to take away everything but the resultants. Now that's pretty cool. So judging by this, I have high tide. I have a high tide that's not as high, but it's a high tide. And I have low tide and low tide. Let me put some more on. Now here's what's really cool. You can actually see the ebb and flow of the water. So as the
Okay, you guys don't look as entertained by this as you should look. Okay, there we go. Okay, thank you.
moon goes around us, you can actually see why differential gravitational force makes tides. So this part's feeling a pretty strong tug, and this part's actually feeling a strange tug, and these guys are being pulled in. And that's differential gravitational force in a nutshell. Pretty awesome program, if you ask me. You can see, like, end of the world, kind of, the moon. That's awesome. So the next time you're at the beach, look for the moon, and you'll be able to tell what tide it is. If you see the moon directly over the, it doesn't matter what phase it is. It depends on where it is compared to you on the Earth. So if you're looking directly overhead and you see the moon, say you see the first quarter moon and it's over your head, well, that's when the moon is closest to your part of the Earth, when it's due south. So you're gonna have high tide. If you see the moon on the horizon, that's when it's actually not, that's when the moon is moved off and it's at that 90-degree angle, and you're gonna have remember the 2 arrows are pointing in, and that's where low tide was. So when you see the moon on the horizon, you have low tide. If you don't see the moon at all, well, maybe it's directly underneath your feet, and that could be another high tide, but it'd be a little tricky. But if you can see the moon, you can tell, if you see it on the horizon and it's getting higher in the sky, you're gonna be going into high tide. That's kind of cool. And if it's above your head and it's starting to go down, then you're going into low tide. Hope you enjoyed the lesson on the tides.
All right, we enjoyed it. So I want you guys to actually think about that. If you check the any weather app, right? I don't know if you guys, I'm like obsessed with checking the weather app, even though I know that 90% of the time it says that it's going to rain. But they tell you when the tides are, right? So you can actually do that. You could go outside and look at where the moon is, and you would know what the tide is doing, right? If we were on the coast. So if you do go to the coast, try that out. You can like quiz your family. Okay, yeah, rain or snow. Yeah, snow, true. Monday it's supposed to snow. All right, let's get this guy out of here. I don't know, I thought that was pretty interesting, right? Kind of going into the physics behind this, right? It's pretty complicated. As you can imagine, it took a lot of thought to figure this out. Okay, so the last thing that we're gonna do is we're going to work in groups. This is something that I've been doing in all my virtual sessions, and we have 4 people. So we'll have, let's see, maybe we can just do 1 group instead of 2. We'll see. So basically the concept behind what we're going to do is this. I made these skeletons of PowerPoints. So, oh, I don't think I can have that there because then I can't see this. What if you can be split in half? What? You guys are coming up with crazy philosophical stuff over here. Okay, so why isn't this opening? That's weird. It's open here. Okay, so I basically made you guys a skeleton of a presentation so that you are going to divide up the work however you want, right? Ideally, you're going to talk to each other. You can also chat in the chat box to each other. You can chat in the chat on the PowerPoint, right? But basically, you're going to be making a presentation about the Apollo missions, a space exploration that NASA did. There's many of them, right? So I kind of zoomed in a little bit. So you're going to be looking at who and when, right? Who funded these, who went, right? When did they happen? You don't have to give tons of details here, but because there's a lot. It's over many years. There's tons of people involved. Then you're going to talk about the purpose. And then I picked 3 Apollo missions for you to give details about. So the first Apollo mission is pretty interesting. It was the first one. There were a lot of problems, right? Apollo 11, right? This was like one of the most famous ones. This is when they landed on the moon. So giving details about that one. And then Apollo 13, also a very famous one. This is when the famous quote was said, "Houston, we have a problem." Right? If you've ever heard that. There's also a movie about that one. And then you're going to add pictures or videos to show what they found, what they learned from these, maybe what spaceships they used, etc. And then what is next? What should we do and how much would it cost? Right? Kind of thinking for the future. Like, okay, we went to the moon. Okay, we're collecting samples of rocks and all this other stuff. What should happen next in space? So I had one for the Voyager missions as well, which are really cool because those are the ones that go to, that went to like Jupiter and Saturn. And they took some really amazing pictures of like the red spot on Jupiter. They found different moons and rings and things that they didn't even know existed. So those are also some pretty interesting missions. And in fact, the Voyagers are still out there in space, right? They're still traveling. And they have on the NASA website, they have where you can see how many miles away it is or how many light years away it is. So what do you guys think? You can type in the chat here. Do you think we should split into 2 groups here, or do you guys want to just stay as 1 group? Okay, Riley says 1. Paige says whatever. Okay, great, Paige. You do 1 by yourself. No. Okay, so then let's do 1 group. Let's do the Apollo missions. And then if we do it quickly and we want, we can do the Voyager ones. But if anything, we'll just go look at the website. So I put 2 websites here. The first one is NASA has like a whole website basically about this exact thing. So I recommend that you use that website to try to find the answers because they're all there. And then there's also this like 10 greatest space missions website where they give some information too. So let me send you guys this PowerPoint. You should have edit access. So you can go into the PowerPoint, put your name, right, because it's your presentation, and then decide who's going to do which slide or which slides, right, because there's 1, 2, 3, 4, 5, 6, there's 7 slides. And then I'm pretty much going to be quiet here and let you guys work. If you have a question, you can type it in the chat, or you can speak and just say, hey, Miss Jamie, I'm stuck on this. And then I'll try to come in and help you guys as needed. But otherwise, I'm just going to let you decide which, oh, you want to do 2 groups? All right, you know what, let's do 2. We'll do 2. You guys ready for this? It's really cool. Have you done breakout rooms yet? Yeah? All right, no one's excited about it. I'm excited about it. Okay, so I have to stop the share. Okay. All right, here we go. Breakout rooms. 2 room, wait, assign 3 participants. Who left? Where'd Riley go? Riley's there, but not able to be in a room. Okay, let's see what happens. Now I don't see Julia. What? Why isn't it letting everyone be in a room? This happened to you before? You couldn't get in a room? Okay, well, you're going to be in breakout room 2 with Alexis. But it doesn't even matter because all you're going to do is go into, let's see, Paige and Riley. You guys do the Apollo missions. So the document that I already sent. And Alexis and Julia, you guys are going to do the Voyager missions, which, like I said, is a lot of really pretty pictures of Saturn and Jupiter. So, oh, I think I only sent it to Julia. How did I do that? Everyone. Oops. Okay, there we go. So Alexis and Julia, you guys are going to go into this PowerPoint that I just sent for the Voyager missions, and Paige and Riley are going to do the Apollo missions. All right, and it's scaffolded on the PowerPoint, so do what you can with it. You can chat in, it looks like, Alexis, you're just going to be in the breakout room chilling by yourself. Actually, you know what? We're not even going to do the breakout rooms. We don't need it. You guys can just chat in the chat of the PowerPoint. All right, so we have Julia and Alexis working on Voyager, and Riley and Paige working on Apollo. So Riley, you click this one. I'll send it to you privately. Let's see. Let's make sure we get everyone in the right spot. Okay. Okay, sweet. All right, so, uh-oh. Wait, no, did I send the wrong one? Page. Okay, so Paige and Riley working together, Julia and Alexis working together. So I'm just gonna go back to sharing my screen just so that people who are gonna watch this later aren't just like staring at us doing nothing here. They'll just see the PowerPoints. So go ahead and I see that Alexis is in the Voyager missions. We're waiting on Julia to get in there. And Apollo, I see. So Julia, you are in the wrong one. It's taking a long time to load? Huh. Okay. But you're getting into it. So that's what counts. All right. So we'll wait for Julia to get in there. And then we're waiting on Riley to get into the Apollo missions. which hopefully Riley. Huh. All right, I see Riley in there. Yep, so you just need to answer the questions in the PowerPoint. Whoops, what did I just do? You can add extra stuff if you want. But you're basically, oh, there we go. I see you now, Julia. You're basically gonna decide who's gonna do which slide, right? I put links on the first slide. There's links at the bottom to NASA websites. Otherwise, that's it. Yep. All right, so I'm gonna let you guys work for a couple minutes, and then I'm gonna see what's going on. And feel free to type in the chat if you get lost or confused. All right, there we go. Ah, I stopped the share again. Huh. Okay, let me try to find out what's going on there. Julia. Okay. Okay. Yeah, it seems like we're having lots of technical issues here. I know it's loading, things are loading really slowly for me as well. So maybe we'll just get all four of us into the same PowerPoint. So let's get everybody in the Apollo missions one. I'll resend the link here. Okay, so everybody go into Apollo and we'll work on that together, and we'll just ignore the Voyager one because I don't know why the Voyager one seems to not be loading super well and we're having issues with it. And then if we have all four of us in one, maybe we can get something done. So if we're all in Apollo here, I think it will work. Okay. I see Paige and Riley. Alexis, did you get that to go to the Apollo missions? Okay, it's still loading. Ooh, you woke up at 6 a.m.? That's rough. Okay, yeah, it's loading really slowly. Okay. All right, I see Alexis in there. I'm doing a virtual session. Goodbye.
Why speak you?
Because he's not making any sound or doing anything. He looks like wallpaper. Okay. Oops. Okay. How long is this? Are you meaning the session? Well, as soon as we're done with this, we're done. But we might be ending this because it seems like we're having too many technical difficulties. Oh, Julia's in there. Okay. You guys think we can do this? We can do this? Yes? No? Yeah? Okay.
I believe.
What? Riley says no. Okay. All right, how about this? If we end the session, if you do any work on this, send me an email and I will give you some extra credit. And then we'll come back next time that we have a virtual session, which is in a while, and we'll talk about these missions a little bit more. So I'll leave this up to you guys as an extra credit option here. So if you want to do some work and you want to split it up, hang around in the PowerPoint. Otherwise, I'm going to end the session just because it seems like, I don't know why Google Docs is loading so slowly. People are having issues. Yeah, you can make a copy, Alexis, if you want to make your own version, that's fine. So you don't have to do it. I wanted us to try to do this, but again, I wish we had a few more people. And if we weren't having these technical issues, because I don't want us to keep waiting around here for it to load and for people to get in. So go ahead and make a copy of it if you want to do your own version of this for extra credit. Otherwise, we're just going to end the session here, okay? So thank you guys for coming. I'm going to mark you as present. And hopefully that gave you a little bit of an idea about this unit, right, that we're talking about space exploration, that we're talking about these big events that actually do impact living things. Okay. So thank you guys for coming. Next time, we won't have technical difficulties and we'll have an awesome time.
Yay.
All right? Bye.
Bye.